Alright folks, welcome back to another Math Notes video. We're in section 3.2.2, solving one variable inequalities. So in this Math Notes we're just going to do a quick review of what it means to solve a one variable inequality, how to do it, how to figure out which way to shade, and what it looks like on the number line. So to solve a one variable inequality, first thing we're going to do is treat the inequality as if it were an equation. So we're going to pretend like the greater than or less than sign is an equal sign, and we're going to solve it like that. So in this example we have the absolute value of 2x minus 17 is greater than 9. So we're going to rewrite that greater than sign here as an equal sign, okay? And we're going to use that to solve our boundary points. So we know that if the absolute value is equal to 9, that this bit inside the absolute value sign could either be 9 or negative 9, because if we had a negative 9 inside this whole thing, then the absolute value of negative 9 would be 9, and the absolute value of positive 9 would also be 9. So to evaluate it, we're going to set it equal to both positive 9 and negative 9. So here's positive 9, here's negative 9. These are two separate problems. To do the positive 9, we're going to add 17 to both sides. We're going to get 2x equals 26, divide by 2, and get x equals 13. And we're going to put an open circle on 13 over here. We're also going to go ahead and solve the negative 9 version. So same process, add 17 to both sides. We get 2x equals 8 this time, divide by 2, and we get positive 4. We're going to put an open circle on positive 4. The reason that we're putting an open circle and not a closed circle there is because when we go back and look at our inequality, there's no equal sign underneath that. It's just greater than. The next thing we need to do is figure out how we're going to shade the different regions here. So to do that, we're going to start testing points inside the different regions. So if we sort of think about our equation there as having like region 1, region 2, and a region 3, we want to test something inside each of those. So the first thing that we've tested is x equal to 0, which would be in the yellow region there, to the left of both of our boundary points. And we find that that is true. So when we plug in, let's make that a little bigger. When we plug in 0 for x, right here, we get 2 times 0 minus 17 is greater than 9. We take the absolute value of negative 17, which gives us positive 17, so positive 17 is greater than 9. That is true. So that means that there are solutions in this region where the 0 was, because that was included. So we're going to shade in that region for sure. Let's go ahead and test the green region there. We're going to use positive 7 as our test point, the same way we used 0 as our test point here. When we test that out, we get 2 times 7 is 14. 14 minus 17 is negative 3. Absolute value of negative 3 is positive 3, which is not greater than 9. So this middle region is not going to be shaded. There's nothing going on in the middle region there. To test our upper region, so that was the middle region. To test the upper region, we're going to choose 15. We're going to use this test point here. We plug in 2 times 15 gives us 30. 30 minus 17 is 13. And so this should be positive 13. That's what threw me off there for a second. So 30 minus 17 is 13. The absolute value of 13 is 13. So that is true. This will be included in our shaded region. Oh, so everything from that boundary. So if we take out our shaded areas there, let's work here. Our final solution is going to look like shaded to the left of 4 and to the right of 13 with open circles on both of those points. Therefore, our solution is down here. X is less than 4 or greater than 13. I'm going to leave you guys with one to try on your own. Let me know what you get for a solution. We're going to say absolute value of 2x minus 17 is less than 9. So try that one out, guys. See what you get. Absolute value of 2x minus 17 is less than 9. Have a good day.